Hello everyone. Today we will be continuing our discussion of unit conversions with a discussion of temperature scales and temperature conversions. So there are really four main temperature scales that we will be discussing today. These are two metric scales, so Celsius and Kelvin scales, and then two imperial scales, the Fahrenheit and Rankine scales. Now, in the scientific world, I would say most of the time you're going to be dealing with either Celsius or Kelvin. So we will start with a discussion of the Celsius scale. The Celsius scale is a temperature scale where 0 degrees Celsius is the freezing point of water, and the boiling point of water is 100 degrees Celsius. All right. This is the most commonly used temperature scale pretty much in most countries besides the US, where we tend to use the Fahrenheit scale a lot. Now, as mentioned before, Celsius is a metric scale. Kelvin is also a metric scale. So what is the big difference between Celsius and Kelvin? Well, the difference between these two scales is that the Celsius scale has 0 degrees Celsius set at the freezing point of water. 0 Kelvin, note 0 Kelvin, not 0 degrees Kelvin. Kelvin, we don't use the degrees sign. 0 Kelvin is what we call absolute zero. And what this means basically is the lowest achievable temperature. So Kelvin, 0 Kelvin is the lowest temperature that can exist, basically. Now, how does this translate to the Celsius scale? Well, as it turns out, 273.15 Kelvin is 0 degrees Celsius. Now, what this basically means is that when we are converting between Kelvin and Celsius, one nice thing is that the Kelvin scale is set up in such a way that a temperature change of 1 Kelvin is the same as a temperature change of 1 degree Celsius. So when we were going back and forth between the Celsius and Kelvin temperatures, if we're given a Kelvin temperature and we want to find the Celsius temperature, we just subtract 273.15. If we're going the other way, we're given a Celsius temperature and we want to find the Kelvin temperature, we just add 273.15. All right? So these are the two metric scales for temperature. Now, the two imperial scales are the Fahrenheit and Rankine scales. Again, the Fahrenheit scale is the most commonly used scale in the US. Most other places prefer the Celsius scale. So in Fahrenheit, the freezing point of water is actually 32 degrees Fahrenheit. So at 32 degrees Fahrenheit, water freezes. The boiling point of water is 212 degrees Fahrenheit. All right. Now, notice that in the Celsius scale, we have 0 degrees to 100 degrees, so that's a 100-degree difference between the boiling and freezing point of water, versus for Fahrenheit, going from 32 to 212, that's a difference of 180 degrees between the boiling and freezing point of water. So when we are converting between Fahrenheit and Celsius, we have to take into account not only that the freezing point of water is 0 in Celsius, but it's 32 in Fahrenheit, but we also have to take into account that a temperature change of 1 degree Celsius actually corresponds to a temperature change of 1.8 degrees Fahrenheit. So these are the formulas over here that we use for going between the Fahrenheit and Celsius scales. If we're given a Fahrenheit temperature and we want to find the Celsius temperature, we subtract 32, then divide by 1.8. If we're going from Celsius to Fahrenheit, we just do the opposite. We multiply by 1.8 and then add 32. The last temperature scale that we'll talk about is the Rankine scale. Now, the Rankine scale is an absolute temperature scale like the Kelvin scale, but it's based on the Fahrenheit scale rather than being based on the Celsius scale the way the Kelvin scale is. I would say of these 4 temperature scales, the Rankine scale is probably the least commonly used one. I don't really know that anybody uses this outside of the engineering world, but for those of you who are engineers or future engineers, this is a good one to be aware of, or to be able to work with, and for the rest of you, it's good to at least know about. So, Rankine, like Kelvin, again, is an absolute temperature scale, so 0 degrees Rankine is absolute 0. And the temperature that in the Rankine scale that goes with 0 degrees Fahrenheit is 459.67 degrees Rankine. So this is 0 degrees Fahrenheit. So kind of like when we're going between Kelvin and Celsius, a temperature change of 1 degree Rankine is equivalent to a temperature change of 1 degree Fahrenheit. So all we have to do when we're going back and forth between these two scales, if we want to go from Rankine to Fahrenheit, we just subtract 459.67. If we want to go from Fahrenheit to Rankine, we are going to do the opposite. We're going to add 459.67. So let's look at an example of how we convert between these different temperature scales. So let's just pick a temperature. So the temperature outside right now happens to be 38 degrees Fahrenheit. So we have 38 degrees Fahrenheit. And let's say we want to convert this into all 3 of these other temperature scales, Celsius, Kelvin, and Rankine. So I would say the easiest one of these to start with is going to be the Rankine scale, because in this case, all you have to do, as you can see over here, is add 459.67. So let's do Rankine first. So what we're going to do is we're going to just take our 38 degrees Fahrenheit plus 459.67. All right. So this is going to give us a temperature of 497.67 degrees Rankine. All right. Now, what else can we do with the Fahrenheit temperature? Well, we can go to Celsius also. So if we want to find the temperature in Celsius, we are going to use this formula over here. So we're going to take our 38 degrees Fahrenheit, subtract 32, and then divide by 1.8. So we have 38 minus 32 over 1.8. All right. So what this is ultimately going to give us is 3.3 degrees Celsius. All right. Last thing, now that we have the Celsius temperature, we can find the Kelvin temperature. So what we're going to do is we are going to basically just take the Celsius temperature and we are going to add 273.15. So Kelvin. We're going to take our 3.3 degrees Celsius, actually 3.33, if we go round to 2 decimal places instead of 1. So 3.33, and we are going to add 273.15, and this is going to give us 276.48. And that's our Kelvin temperature. All right. Thank you for watching. Hopefully this helps, but as always, feel free to let me know if you have any questions.